Passport to Advanced Math Lesson 10 is solving systems of one linear equation and one quadratic. This is a higher level process, but no one understand there are strategies that you could use to help you out with them. So the first strategy is anytime it's a calculator based question, you could always solve each equation for y and then graph both equations, right, or both functions and look for the intersection. And no one understand a line can intersect a parabola at most 2 points. All right. Next is you could use substitution. The way we use substitution with solving systems in a lot of these problems. The substitution method is going to be the best one. And some things you might want to review is factoring and using the discriminant, right, can assist. Remember, in a quadratic formula, the discriminant is the b squared minus 4ac. So if you evaluate this and your discriminant is equal to, so if you get a discriminant with a value of 0, you know there's one intersection. If your discriminant is positive, you're going to have two intersections. And if it's negative, you're going to have no intersection, right? That is something that will help. Now, one thing you must understand, right, that y equals a number is a function that represents the graph of a horizontal line. So if I go to graph any function in the form, say y equals 1, I would go to 1 on the y-axis and draw a horizontal line through it. Okay? Now, the first function, or first question, talks about you're given y equals 3 and then y equals ax squared plus b. In this system of equations above, right, a and b are constants. For which of the following values of a and b does the system of equations have exactly two real solutions? Now, here's the thing. You can graph this in the calculator, right? But just by knowing simple basics, right? If I graph the line y equals 3, I graph the line y equals 3, it would look like this. Now, just by looking at each of the functions here, if this is y equals negative 2x squared plus 2, I have to know the vertex of this is going to be 0, 2, and that's going to open down. And if I plot 0, 2 and it opens down, will that ever intersect the graph? No. The next one is negative 2x squared plus 4. If I look, this is going to have a vertex of 0, 4, right? And because a is negative, it's going to open down. So right away, this would have two real solutions, right? So letter B would be my answer choice. If I do look at the others, this would have 0, 4. Letter C would be 2x squared plus 4, 0, 4, but it would open up because A is positive. This would have a vertex of 0, 3 and open up, but that would only have one solution. Okay, now I could, right, go to my calculator, plug in 3, and then I could just substitute these values in, right, such as negative 2x squared plus 4, hit graph, and I'll see that intersects twice. And if you look at the next one, negative 2x squared, right, if I go plus 2 and I hit graph, I'll see that doesn't intersect, so then I move on. So you could substitute A and B and then graph it on the calculator. The next one, in the xy plane, a line has the equation y equals c, right? So you know right away that's a horizontal line. For some constant c intersects a parabola at exactly 1 point. If the parabola has the equation y equals negative x squared plus 5x, what is the value of c, right? Now, The key is you need to find the vertex. In order for a system, right, with one linear function and one exponential function to have one solution, that means the vertex has to be on the line. So if I graph that line y equals c, right, I don't know where it's at, but I know it's somewhere like here. I know once I find the vertex, this parabola, right, is going to intersect it at one point at the vertex. So I need the y value, right? This is y equals c. So I need the y value of the vertex. That would be c. So if I go to my calculator here, right, I'm going to plug in the function they give me. Oh. So right away, I'm going to go negative x squared plus 5x. And when I graph this, right, you see your vertex is right about there. Now, if I hit trace and go to the top of that, right, I can kind of get an idea that my vertex is roughly going to be 2.5. So right away, if my vertex in here is around 2.5 and y is 6 point something, I'm guesstimating. How do I find the exact? Well, I'm going to hit second, right, trace, and I'm going to look for the maximum. And it says left bound, I'm going to hit enter. And I'm going to go over and say right bound. And then I'll just hit enter again. And what is my y value? 6.25. Okay, these generally will come out to a nicer number. Now, if I look at this too, I could also, if you remember completing the square, I can complete the square, find x, or if you remember finding using the opposite of b over 2a, you can find the x coordinate by doing negative 5 over 2 times negative 1, which is going to give you negative 5 over negative 2, which is 5 halves. Now, if x is equal to 2.5, now I can plug that in. Negative 2.5 all squared plus 5 times 2.5, right? And when I plug that in, negative, open parentheses, 2.5, close parentheses, squared. And then I'm going to do plus 5 times 2.5, right? I'm going to get 6.25. Okay? Now the next one. If xy is the solution of the system above, what is the value of x times y? So what I have to do is find an ordered pair solution, and then I have to multiply these together. Now, here's the thing, right? This is a no calculator problem, so I can't solve it, using the graph. So what I'm going to do is I can do one of two things here. I can plug the value of y in here. Okay, so I would get 2 times x squared plus 6 equals, distribute to 2, 2x plus 6. Now what I'm going to do is solve this equation. So anytime I solve a quadratic, right, 2x squared plus 6 equals 2x plus 6, first thing I do is set it equal to 0. So subtract 2x, subtract 6, and 2x squared minus 2x, 6 is eliminated here, equals 0. Now, the easiest way to solve this quadratic from here is to factor it by looking for a GCF. Pull out the 2x, and I'm left with x minus 1. So I'm going to set 2x equal to 0, and then I'm going to set x minus 1 equal to 0. So x equals 0, x equals 1. Now I know if x is 0, when I do 0 times something, it's going to be 0. And x times y, 0 is not an option. So I know I'm going to use x equals 1. So when I use x equals 1, y equals 1 squared, which is 1. So an ordered pair solution here would be 1, 1. And if I do x times y, that would be 1 times 1, which is letter A, 1. Okay, the next one. This is a more difficult one. How many ordered pairs satisfy the system of equations above, right? So how many times does this system intersect? And right away, it's a no calculator problem. So what I'm going to do here is I'm going to take the value of y and plug it in up here. So I'm going to say x equals 2 times 2x minus 3 times x plus 9 and then plus 5. So now when I simplify this, I'm going to get 4x minus 6 times x plus 9, all plus 5. FOIL this out. X equals, that's going to be 4x squared plus 36x minus 6x minus 54 plus 5. Now, simplify it even further. 4x squared plus 30x, negative 54 plus 5 is going to give me minus 49. So right away here, I'm going to go ahead and set this equal to 0 and look to solve this quadratic. Now, first thing I'm going to do, remember, if this quadratic has two solutions, that means it's going to have two intersection points. If it has one solution, it's going to have one, and if it has no solution, it's not going to intersect at all. So I'm just going to evaluate the discriminant here. 29 squared minus 4 times negative 49. Now I know that's a lot of algebra when we look at the discriminant, right? Use number sense here. You know 29 squared is going to be a positive number. Then I'm going to have and I'll just say something like similar to 30 squared, which is 900, right? The key is knowing if this is 0, if this is a positive number or a negative number. But just by knowing a negative times a negative is a positive, I know I'm going to do a positive plus a positive, which automatically tells me it's a positive, which means it's going to have two solutions. So there would be two intersections here, letter C. The last one here, okay? I have f of x equals, the function f and g are defined by 8x squared, or 8x squared minus 2, and g of x is negative 8x squared plus 2, are graphed in the xy plane above. The graphs f and g intersect at the points k0 and negative k0, so those 2 points. What is the value of k? Well, here's the thing. Once you know both functions, all you're basically going to do is set these equal to each other. And now all I'm going to do is solve for x. Add 8x squared because I know I have to solve a quadratic. Subtract the 2, right? And I get 16x squared minus 4 equals 0. Uh-oh. This ends up being a square root problem where I could just add 4 to both sides. 16x squared equals 4. Divide by 16. X squared equals 4 over 16. And now, if I reduce that, x squared is equal to 1/4. So, take the square root of both sides. X equals plus or minus the square root of 1 over the square root of 4, which is plus or minus 1/2. So, k is going to be letter B, 1/2.